All right, so as you guys watched and worked through the practice problems from part 1 of the video lesson for 6.2, you saw that you can find the product or you can multiply the two fractions when it comes to our rational expressions. So in this case, it's now saying find the quotient, which means can you divide those? So if you, when you watch part 1 and you work through the practice, you're like, okay, I got it. Just because it says divide doesn't change a lot. It's just going to mean that the second fraction needs to be flipped, or you multiply by the reciprocal is another way of saying that. So the first step is just going to be rewrite it with a flipped second fraction and change your sign to multiplication. So if you just do that every time, that pattern there, then you will be able to be successful with these. So what that's going to look like is you're going to flip the second, change the sign. So if we flip and change every time, it's going to look like this for this specific problem. So 4x over 5y times now, so change the sign from a division to a multiplication because we're going to flip it, which is the same concept as multiplying by the reciprocal. Now that you've done that, you solve it like we did part 1. So when we worked through our products. So in this case, we've got 4 times 8, so we know that's 32. X and then x to the 4th means that we have x to the 5th. On the bottom portion of the denominator, we have 5 times 10, which is 50. And then we've got y and then a y squared, so we've got y to the 3rd. Now we still need to make sure that we look at that and say, is there a way to simplify that any? We see that it is something where we have a even number, so we could go, okay, 16 and 25. Is there anything else? Okay, no, not in this case. So we would look and say 2 divided by 2. So that leaves us with 16x to the 5th over 25y to the 3rd. And since the numerator and denominator have different variables, there's nothing we can simplify with those. So that is the steps that you're going to do every single time. So let's look at another one, example 6. We know that we've got to change our sign to division and flip the second fraction. So that would look like, let's just rewrite this here, x squared plus x minus 12 over 4x plus 20 times, so we're now multiplying, and then x squared minus 25. And then x squared minus 9. So we flipped that second fraction. Now that we have done that, we've set it up to where we flip the second fraction, change from a division sign to a multiplication sign. We solve it like we did in part 1. So with this, we've got multiple factoring. We've got a greatest common factor, and we've got 2 dots. So let's take a look here as we break these down. We're going to have an x and an x for our x squared. Then we would have a positive 4 and a minus 3. We've got a dots here on the top right. So with the dots on the top right, we know that anytime you have dots, you got a positive and a negative. So x and x, 5 and 5. Then on the bottom, we also have another dots. So we know that we're going to have a positive and a negative, an x and an x. Ooh, whoops, wrote it on the wrong spot. X and an x. And then a 3 and a 3. And then on the right, we know 4 goes into 20. So that leaves us with 4, and then x plus 5. Now that we've broken everything down, or we have factored it out, so as we factor these out, we look for locations either in the numerator and the denominator of the same fraction, or we look diagonally to see is there anything we can cancel out. So we know we've got an x minus 3, and an x minus 3. Those are now canceled out. We've got an x plus 5, and an x plus 5. Those are canceled out. And we take a step back. All right, I know I see a 4 and a 4, but one of them is x plus 4 and one of them is 4, so we're going to leave that alone. So what that's going to look like when we write it together is x plus 4, x minus 5 over 4 times x plus 3. All right, so that is finding the quotient. Now there's one other way to find the quotient where you are given a complex fraction. So with your complex fraction, you're still going to do the same concept of you're going to flip. So you got your reciprocal, and then you're changing the sign to multiplication. So what this would be, and I'll write out each of the steps here. You've got x squared minus 25 over 5x plus 20. And then it's another way of writing this is divided by x squared plus 7x plus 10 over 3x plus 12. So that's more like example 5 and 6, what we saw. And so now that it's like what we saw in examples 5 and 6, we can change the sign and flip the second fraction. So I'm still going to rewrite this x squared minus 25 over 5x plus 20 times, so now we're multiplying, and then the 3x plus 12 goes on top, and then the x squared plus 7x plus 10 goes on the bottom. All right, so that's a lot of flipping and rewriting and all that stuff, but take the time to do it, because it'll allow you to be successful with these problems, because there's a lot of steps. There's a lot of stuff to keep up with all the dots and factoring and greatest common factor all in one place. So we want to make sure that we keep track of where everything's going, keep it nice and organized, and then you can solve algebraically. So in this case, we have a dots to start with in the top right, so the numerator on the first fraction, so we know that we got a positive and a negative. We got x and x. Square root of 25 is 5, so 5 and 5. All right, then in the denominator of the same fraction, we know 5 goes into 20, so we take out a 5. 20 divided by 5 is 4. So those are both factored. Then in the numerator of the second fraction, we see there's a 3 that can be taken out because 3 goes into 12. So 12 divided by 3 is 4. Then in the bottom portion here, this is where you can do your x factor, your x games, your grouping. You can kind of take your pick. We got an x and an x. We got a 10 and, or excuse me, a 5 and a 2 for our 10. So we got a 5 and a 2. They're both positive, so these are both positive. All right, now that we have all of that set up, we can look for anything that's going to cancel out. All right, so we see that we have an x plus 5 and an x plus 5. So those are gone. We see an x plus 4 and an x plus 4. So those are gone as well. Then we've got x plus 2, x minus 5, 3, and 5. So nothing else there. So we would now have 3 times x minus 5. And we'd have a 5 times x plus 2. All right, and that's if we have a complex fraction that we are asked to find the quotient.